Today, a venomous project kicks off Extreme 4x4 as Ian and Jessi build a Poison Spyder Rock Rod.
You're watching Power Nation.
Welcome to Extreme 4x4 and our most ambitious project yet.
We've been thinking about what we've been missing from our build list. We got Cheap Jeep, we got AJ, our ultimate Jeep.
We pulled a Ranger out of a wrecking yard and we're building a Baja truck out of that. That's going pretty well. And we even threw in a couple tow rigs just for the hate mail.
But when you start planning your own rig, you begin to seriously think about a tube chassis. Like this one that we had brought in from Poison Spyder Customs.
Now you can build your own frame, and a few years ago that was your only choice, but you run the risk of it not working, and plus you're going to spend hours or even days and months building and designing one of these things.
But why go through all that when you can buy one for $3,900? You know it's going to be square, you know it's going to be straight, level, and it's actually going to work.
That's why nowadays a pre-built chassis is a great option.
Clifton Slay is the owner of Poison Spyder Customs, manufacturer of all sorts of crawler accessories including stingers, bumpers, even turnkey buggies and cages. Hey, I'm Jessi.
Clifton and Spyder fabricator Timmy Turner made the trip from Denver, Colorado to personally deliver our Bruiser chassis to Extreme. These guys build awesome rigs, like their latest here, Suicide Sally.
Ours may not be as spiffy, but with the hardest part finished, we set out to build a competent trail rig. One with bulletproof axles, custom 4-link, and plenty of power that will hopefully make the designer proud.
I can't wait to see what you guys make of it. I'm sure it's going to be an awesome machine, and we'll be back and we'll see you on the trail.
Our Bruiser 8 chassis is constructed with 1 3/4 DOM tubing and comes welded complete with winch mounts and shock mounts.
Now, the first thing we're going to do today is we're going to slip the engine, transmission, and transfer case in there, and then we're going to start planning to get this thing sitting on some diffs.
And for those of you who are wondering when we're going to show you how to swap out gears, well, today is the day. For the drivetrain goodies, we decided to go with the crate engine and a crate transmission from GM Performance. We flipped through the catalog and chose a V8 LS1 because it delivers a good torque curve that peaks at 365 at 4,000 RPM. And because it's aluminum, it'll give us a good power to weight ratio.
Now behind that LS1, we're going to be slipping in this 4L65E electronically controlled transmission. Now this is a great trans to put in behind a small block, and it's a 4-speed unit with a 3.08 first gear for slow speed crawling, but it also has a 0.07 overdrive for when you really want to fly through the dunes. Now the best thing about one of these packages from GM Performance is that this isn't some wrecking yard find that someone rebuilt and crated up. This is a brand new engine with all the newest stuff right off the assembly line.
The next item to be going on our rock rod is a transfer case. We wanted to stick with our crate theme, so we went to advanced adapters for an Atlas II. And since the Bruiser will be spending most of its life on the rocks, we went with the ultimate low 5/0 gear ratio, which means that when I spin the input shaft, the output shaft will spin 5 times slower than the input, giving us speed reduction and torque increase. So with the transmission in first gear, we'll get a gear ratio of about 15:1. And of course, Advanced sent us all the adapter plates that we need to get this bolted up to our transmission. Safety?
Yep.
Need to go more.
Look, my head fits right through there. That's good. And even fits back through there.
That's even better. Now it's time to start mapping out our motor mounts and the transmission cross member. And the LS1 has excellent bosses, making this a fabricator's dream, because I can mount them here, here, or even here. So I got a lot of options to choose from. I will cut out 1/4-inch plate for the engine mounts. Then with the holes laid out, I'll drill them using a drill press. Then cut the tubes for the urethane spring eye bushing we got from Prothane. I'm gonna finish welding this piece all together while it's bolted onto the engine and onto the frame. because this frame is going to act like a jig and not allow it to twist from the heat of the welding. Now if I were to finish welding it out on the table, it would deflect, and when I would try to line these bolts back up, they wouldn't line up, and that would really suck.
With the engine firmly on its mounts, I'm going to hang the transmission and the transfer case off this ratchet strap. Then I'm going to go ahead and take one piece of tubing and run it underneath for the mount. And now it's time to deal with the axles. Now we've been opening a lot of crates on this project, so why stop now? Well, because you asked us to. You wanted to know when we were going to do a boneyard axle buildup.
So here they are, a couple Dana 60s that we got from Condon's Auto Parts, a great source for used four-wheel drive parts. And we're going to build these what we consider bomb-proof axles. But before we put gears in this front axle, it needs a little work first.
So I'm going to tear into the rear axle, and I'm going to replace the carrier with this Detroit locker we got from Track Tech, and then I'm going to spin that with some 513 gears we got from Superior Axle and Gear. Now these gears will give us a great bottom end run, but with our tire combination we'll still have half decent top end speed. Now a differential is a mysterious item, and these gears are the first part of the puzzle as to what goes on inside that diff. As you drive your truck, power from the engine is split in two and sent to either wheel by the differential. Whether you have an open diff or a locker, the real work inside the diff happens when you turn a corner and the wheels have to travel at different speeds. While the gear reduction and power splitting are handled by the ring gear and drive pinion, the differential action uses the side gears and pinion gears, sometimes referred to as spider gears. The ring and drive pinion are still turning the same speed, but with the spider gears working their way around the side gears, the input speed is divided between both wheels, allowing them to travel at different speeds. The Detroit locker replaces those spider gears with a spider and clutch assembly that's going to maximize traction, but it's still going to allow for that differential action. Now, replacing a ring and pinion may seem like a big job, but trust me, if you can rebuild an engine, you can easily swap a set of gears. With the rear 60 on jack stands, I will pull the axle shafts, then pop out the carrier. When starting with an existing gear set, I like to check the feel of the pinion rotating torque. Then pop out the pinion gear and remove the bearing races. Now here's a trick when you're doing this job. You're going to have to press that new bearing onto the pinion. So I'm going to take this old bearing and I'm going to cut the cage off of it. A pair of side cutters. I'm going to peel it open and pull all the rollers off. I'm going to use this inner part on top of the new pinion with a piece of tubing to press that new bearing on. Now the carrier, the shims to set bearing preload go between the side bearings and the carrier themselves. And we're going to have to take this apart and put it together a whole lot during this setup. So I'm going to take the old bearings, I'm going to grind out the inside with a die grinder until they fit on and off, and we can take it apart easier. Check the fit on the setup bearings. Install the new ring on the Detroit locker and torque the bolts to 110 foot-pounds. Place the new Detroit locker into the rear axle and using a dial indicator, move the carrier back and forth. This is the total amount of shims we need, 78 thousandths of an inch. With that number recorded, install the pinion bearings. Install the pinion shims into the carrier, followed by the bearing race. And install the pinion into the rear axle and check the rotating torque. With the pinion in place, we will set the carrier in the housing and move it back and forth again, measuring in the same location with the dial indicator. This will tell us how many shims are needed on the ring gear side of the carrier. With the carrier removed, we pull the setup bearings and place 50 thousandths worth of shims on the ring gear side. Then the remaining 38 thousandths plus 15 thousandths for bearing preload are installed on the opposite side. With the bearing caps torqued, we're going to go ahead and check backlash using a dial indicator. Now you want between 4 and 9 thousandths of an inch worth of play between the ring and the pinion. Now if you have too much backlash, you take a shim from this side of the carrier and move it to this side. and that will move your ring gear closer to the pinion. If you have too little a backlash, you take a shim from this side of the carrier and move it to this side, moving that ring gear away from the pinion. Once you have the correct backlash, we can check the gear tooth pattern with the paint, and if everything looks good, we take it all back apart, put the new bearings on the carrier, and assemble it for good. Our rear 60 has a new Detroit locker and set of Superior gears in there. I'm going to pull out these old axle shafts so we can measure them and have Superior make us some new 35 spline units. Then we can go ahead, get this axle on some tires, get it underneath the back of the chassis so we can start measuring for links.
We went to Nitto Tire for these 38 by 15.5 mud grapplers. These have always been a great off-road tire thanks to their computer-designed tread pattern and their super thick side lugs. And they've been working on the rubber compound, so they're biting really awesome on the rocks.
We wrap those tires around a set of 20 by 10 Mickey Thompson Classic 2s that we got online from National Tire and Wheel. Now these are a fully polished aluminum wheel, and they have steel inserts in the lug holes for extra strength at the flange.
With the axle back here, we can go ahead and start figuring out our ride height, axle center line, and then we can start planning out our 4-link system. Ready?
Yep.
A link suspension is something that we could honestly do an entire show on, and we will later on. But for this chassis, we had the ability to look at other bruisers and talk to other builders to get a good starting point. With the approximate measurements that we just took, I entered them into our 4-link calculator, which states that we have about a 30% anti-squat. Now what's anti-squat? Well, when you push on your gas, your rear end squats down. So if you have a lot of anti-squat, you're going to have a lot of axle wrap and a lot of wheel hop. Now if I move those front upper links down 1 inch, it's going to change the entire geometry and giving us about a 4% anti-squat, which is almost 0. So that's a good neutral zone for us to start because we can always change those links at any time.
Now before we even think about a link system for the front of this truck, we're actually going to need an axle. Now this center section is going to be the beginning of an ultimate front axle for this truck. And I'm just going to set it in place on these jack stands so we can get an idea of what kind of tube lengths we're going to need.
That 4-link calculator also measures link lengths for us. So we're going to be using DOM tubing with tubing adapters. And once I get all of these welded in, I'm going to be putting in 3/4 inch heim joints that we got from QA1. They got a Teflon block for lubrication, and they're heat treated for heavy duty applications. The list of items that need to be added to this chassis before we send it out is pretty long, but with a good plan of attack, we should be able to bang them out in no time. The first item is a spare tire mount. Don't breathe in the galvanized fumes. Can I go?
Now this chassis is designed to accept the Jeep TJ front hood and grill shell, and we got these pieces from 4-Wheel Drive Hardware, a great source for Jeep parts. Now when we drop this grill shell in place, you'll see that it's got to be trimmed around all these tubes, and when that's done, we can make mounts for these holes right here.
This chassis was designed with a gigantic storage area right in this spot over here. And we don't want to take away any of that space by putting a fuel cell right in the middle of it. So we're going to Rock Valley to have them custom build one for us. As soon as I get the measurements, I can make a template for them. I'll mock up a fuel cell by cutting a template out of this cardboard box. With it in place, I can check the location for our mounting points.
Poison Spyder included these trick little hood hinge blocks that we can weld on to hold our hood in place. With them in, I can check the location of our mounting points. then weld the blocks to the chassis. For a radiator, we spotted this little beauty at the SEMA show and earmarked it for this project right away. It's from Flexolite, and it's a heavy-duty 2-core aluminum rad with built-in fan. But the coolest part is these adjustable mounting brackets with these little T-slots. And this thing can fit into almost anything. You can even move the mount right to the back. This will tuck right up into place under the tube, and these mounts can be bolted into place.
Before we can even begin to think about driving this truck, we need to get some seats in there. Since we're going to be spending a lot of time in this rig on the trail, comfortable seats are an important decision that you need to make. So we went with Mastercraft for one of their fully suspended sportsman seats. And they put on this new Cordura fabric for us that's not going to fade in the sun, and it's going to be resistant to sand and dirt also. And if you ask really nicely, they'll even put in your own logo for you. Once we get some measurements, I can build them out. Move your foot over. All right, thanks. I'm going to use 1/4-inch steel by using the hydraulic press as a brake with these dies that we made out of angle iron and C-channel. I'll add some corner gussets for strength, measure and drill the holes, and with the sliders bolted on, I can weld the mounts to the chassis.
With the seat in place, we can go ahead and install our seat belts. Now, we also went to Mastercraft for a comp-certified 3-inch wide belt, and we got it with a clip attachment. So once we weld these brackets that we got from A&A Manufacturing to the chassis, we can just clip the belts in and we're good to go.
For the steering on this monster, we're going to go with a full hydraulic system that we got from PSC. Performance Steering Components has been in the industry for over 20 years, and we went with their hydraulic crossover system. It comes complete with a pump, a reservoir, the ram, return hose, and even an orbital valve. I'll need to fab up a mounting plate for the valve, tack it into the chassis, then bolt it in.
We finished up most of the welding on our Poison Spyder Bruiser 8 chassis, and now it's time to start dealing with a custom front axle.
This axle took a lot of planning and a lot of research to truly become a bomb-proof axle, because building an axle from scratch isn't as easy as throwing in some lockers, some shafts, and new gears.
But the nice thing about doing it this way is not only can we set a custom width, but we can go through the entire axle and analyze every part and eliminate potential weak points. Ready?
We started last week by removing the old axle tubes, which will now be replaced by these 3.5 DOM half-inch wall pieces that we got from Industrial Tube and Steel.
We cooled down the axle tubes so they'd shrink, making them easier to press into the housing. At the wheels, we opted for some Kingpin inner Cs. Now, we got these from Crane high clearance axles, and they come in multiple tube options, and they're full chrome moly pieces for extra strength. And these things are ready for any custom application.
Kingpin front axles are getting harder and harder to find, so by using these pieces from high clearance, we can turn a ball joint axle into a stronger Kingpin style.
There you go.
And when you start messing with the front axle components, you're going to want to keep in mind the caster angle, which is the relationship between true vertical and the line drawn between the upper and the lower Kingpin. And we're going to put ours at about 6 to 8 degrees positive. Can I have that angle, Fanny? Thank you.
Got it. When you're starting with an empty housing like we did here, you have no baseline to determine your pinion depth. So you're going to need to invest in a tool called a pinion depth checker, like this one we got from T&D Machine. It will ensure that your pinion is sitting in the right depth of the housing as it's related to the ring gear, and that'll ensure a good gear tooth pattern when you're all finished. Now, this is a pretty extensive tool, and it's not for the amateur, but if you pick one of these up, you're going to be the envy of all your four-wheeling buddies.
We're going to be installing a matching set of 513 Superior gears on a Detroit locker in the front axle. but these are reverse rotation gears. And you can see that just by looking at the different angles on the teeth. The benefit of having a reverse rotation is that you're going to get your pinion above your axle center line, which is going to give you better clearance and better drive shaft angles. Now, some people will take the rear housing, move it to the front, build this multi-million-dollar axle around it, and leave the standard gear set. Now, the problem with that is that you're going to have a low pinion, and a hypoid gear is built with a drive side and a coast side. And when you move that power to the coast side, it makes it super inefficient, it's going to starve your gears of oil, and it's going to lead to premature failure.
With the pinion depth set in the housing, we can pull the checker out and begin to install our superior gears. And we've got our shim pack, our dial indicator, and all of our special tools ready, and this takes a lot of work. And if you missed our episode last week on how to set a set of gears up, don't worry, because after the show, if you go to our website, we're going to have a page on there that's going to take you step by step on how to install a set of gears in a Dana 60.
Duplicolor's Grabber Green happens to be a distinctive color on all Crane high clearance axle parts, so I'll give them a good coat before they're bolted up. To get this outer knuckle on, Superior sent us this super cool Kingpin rebuild kit. It comes with all the necessary components.
With our spindles in place, we can start planning our brake system. Now, I went to Dynatrack and had them send us one of their unit bearing elimination kits so we can run this rotor support and a hat rotor, and then eventually run some multi-piston calipers on this axle.
We got our front axle under the chassis, and by using some of the similar suspension geometry that we used on the rear, I can go ahead and start planning out my front suspension.
On the rear, we're ready to start installing our new coilover shocks. Now, these Bilstein 9100 rock crawlers have a lot of new technology in them. A standard coilover shock requires fast cycling or high-speed movement of the piston inside the shock. Well, these shocks are designed to work under slow-speed movement, which is what you want in a rock crawler. Now, we're going to put them together with some Eibach 14-inch, 200-pound springs. We got 2 for each shock. We'll set them up in the rear, lower the truck down, check the ride height, move them to the front, and do the same. If the front's sitting a little bit lower, we'll pull one 200 out and swap in a 250 and see if that can change. We'll just put it all together with some tabs from A&A.
Link is very similar to the rear, except for the fact that the lower links are not as triangulated due to engine clearance issues and mounting point issues. But that's not going to affect our anti-squat or instant center, although it will affect our body roll, which is the roll axis, which is the body wanting to roll on itself. But as long as all the mounts are at the same height, we should be A-OK.
With the chassis sitting on its coilovers, we can go ahead and take the first measurement for our drive shaft. Then we'll come back out and pull the springs out of those coilovers, compress the suspension, and then extend it and take those measurements, then we're ready to order our shafts. You can see we made a lot of headway on this tube buggy since the last time you saw it.
Yep, as soon as all the fabrication was done, we stripped her down, put her on the trailer, and took her to the paint shop. And to our friend John Bohannon at Bohannon's Concepts. Once we got the Bruiser 8 inside, Hutch, our right-hand man, helped me prep the buggy, which would have taken me forever to do it by myself. Goodbye, cruel world. Goodbye. Next came a couple coats of red primer, followed by 3 coats of PPG's Viper Red single-stage paint.
It was nice of Hutch to give you a hand prepping this chassis.
Yeah, he's a trooper.
And with it back in the shop and in finished paint, we can start to bolt it back together. And we're going to start with a disc brake conversion on this rear Dana 60. The Dana 60 rear drum is not only massive and heavy, this thing can pack full of dirt, water, and mud, making it absolutely useless as a braking system. So we're going to convert the rear axle to disc using this bracket kit we got from Blue Torch Fab. Now this is going to bolt up in place of the stock backing plate, and then we can go ahead and install the rotor and the caliper. This kit uses a 1980 GMC 3/4 ton front rotor and loaded caliper. Tighten the caliper bracket bolt, making sure the bleeder screw faces up.
To stick with our red and black theme, I'm gonna go ahead and two-tone the dash. But before I can do that, I've gotta lay out all our gauges and our switch panel. Now, because this is a custom rock rod, we went ahead and chose a universal wiring kit and switch panel system from Painless Performance. Not only does this kit come with all of the switches that we're gonna need, but it also comes with circuit breakers. So if we get a short out on the trail, all we have to do is find the problem, reset the circuit breaker, instead of carrying a bunch of fuses with us. After marking the location for the panel and gauges, we can cut it out with the body saw and mount it in place. With the hole cut out for our switch panel, I can move on to our gauges. These are our sport comp gauges that we got from Autometer. They all have that brushed aluminum look, so it's going to complement this panel, and the whole dash is going to look primo. Now, being the fact that we don't have a very big dash, we also had Autometer send us these roll bar mounts. So they'll just hug the bar like this, and then the pod will go on just like that, so you can hold on to the little ones, and you can put them anywhere you want. It's all your choice.
The last piece to go on this rear axle is going to be a new indestructible diff cover. And we got ours from Crane High Clearance. Now, it's a chrome moly alloy cover, and it's a lipless design. So when you install it, you're just going to set it on the axle housing, line it up, and check to make sure that the cover isn't overhanging on the bottom side of the diff. If it does, you just grind a bit of that cover away, and then it won't get hung up on any obstacles or rocks. Now, Crane also raises the diff fill plug up on the cover, so if you tilt your axle to compensate for pinion angles, you'll still have enough fluid in there for your gear set. Now, the brakes on the front axle are a little bit different. If you remember, we had Dynatrac put together one of their unit bearing elimination kits and then modify it to fit this Crane link pin spindle. But we're going to change it even more. Normally, this thing would have the rotor pressed on from the back side just like the rear axle. But we're going to have this machined to accept a 2004 Dodge Hat style rotor. This rotor is bigger and it's going to give us more braking power, but the biggest benefit is we're going to be able to use a 2-piston caliper in the front. Now, we got this one out of a junkyard used for mock-up, and I've marked the center line of our new rotor on this axle, and I just have to build a bracket to fit this. Now, the biggest benefit for us doing this is if we ever want to upgrade later to a set of aftermarket big brakes for this axle, we just have to remember that everything fits a 2004 Dodge. To measure for the bracket, set the caliper in place and mark the 2 center lines. Using some cardboard, we'll make a mock-up and then transfer it to 1/4-inch plate and cut it out.
Now that we got the gauges and the switch panel in, we can begin to plan out our wiring harness.
Now, wiring a tube buggy is a little different than just replacing a harness in a stock vehicle. And because of the serious conditions that a harness can see, you gotta plan it a little bit differently.
And when you're planning out a harness, the first thing that you're gonna have to do for anything is determine how many circuits you're gonna need. So we just simply made a list, because we're gonna need circuits for our off-road lights, our cooling fan, our fuel pump, our tail lights, our power supply to the gauges in the switch panel. Anything else?
We probably need a power feed for our engine harness, which we'll use to control this all-aluminum LS1 small block that we got from GM Performance parts. Now, if you remember, we mated that engine to a 4L65E computer-controlled transmission. But the nice thing is this ECU and harness kit that we got with that package will control both the engine and the transmission at the same time. Now, there's a lot of wires to hook up and things to mount, but everything can only be plugged into one spot.
For the items that we're going to be sending power to, we need to figure out what type of circuit each item needs. Some of them are going to use a relay, and others are going to use a simple circuit. Our rock lights, for example, are LED units, which draw very little current, so we can just control them through a switch. But our electric fan, our fuel pump, our off-road lights draw a lot of amps, so we're going to have to run them through a relay. And a relay is simply an electrically controlled switch that gets its power from a separate 12-volt source. So when I flip the switch to the cooling fan, the power goes through the relay, which activates an internal switch, pulls the power from the source and goes straight to the fan, which eliminates the fact that we might burn out our switch.
To keep things a little bit more organized when we start to lay out that harness on the floor, I'm just going to take some rough measurements of where we want the main harness to run through this tube chassis. This is going to make things a lot easier when it actually comes to pulling wires through this mess of tubing. We're not going to have a bunch of wires in a rat's nest trying to figure out which way they go. We'll be able to bundle them together and actually make a main harness.
A good starting point for any wiring harness is a floor layout. With the measurements that Ian took, we can go ahead and start doing that right now. Thanks.
This is also a good time to actually draw an official wiring schematic for your harness, and that way if you have any problems in the future, it makes it easier to diagnose.
We never know what kind of elements our bruiser's going to see. So when we talked to Painless Performance and told them about our project, they had suggested the Off-Road 6 kit because it comes with these waterproof switch boots and this waterproof fuse panel. So it's going to go ahead and keep all of our electrical stuff dry. We are going to use a spliced main power feed for each switch. Once the main power wire is in the box, we tap into it for constant power for the off-road lights and cooling fan.
Now that all the wires are run, I will start to bundle them together into a harness. I have completed the schematic of the entire system, and by following it, I can easily see that we are not going to have any major problems. The most common problems when building your own harness are unfinished circuits, unprotected circuits that don't have a fuse or a circuit breaker, or a bad ground. Now, when you come up with a wiring schematic, the best thing to do is just think of it like plumbing. The electricity's got to flow through a circuit breaker or a fuse that will act as an automatic shut-off if something's wrong. It'll have to go through a switch to control whatever you need to control, and that's like a manual shut-off. And then it has to travel all the way to the device that you need to power. And then once it reaches that device, it needs to go to ground to return back to the battery. Now you can do that through a ground wire right back to the negative post of the battery, or you can use a common ground. And that's just screwing it to the chassis, and then it'll use the metal in the chassis or the vehicle's frame to go all the way back to the battery.
There's a circuit that people have a lot of problems with, and that would be your headlights and your taillights, or your brake lights and your blinkers. Sure, you've seen it when the guy's driving down the road, hits his brakes, and his front turn signals come on. But there's a way to prevent that, and that's by using a diode. What happens is when you put the power to the switch, you're going to have current to your headlights. It's also going to go through the diode and out to your taillights. You flip the switch the other way, you're going to have power out to your taillights, but the diode's going to stop it. So if you put a diode at your brake lights, your blinkers won't come on when you hit the brakes. So for that guy driving the 32 Ford in my neighborhood, go and buy yourself some diodes.
With the switch panel installed in the dash, we just have to run the harness throughout the entire chassis. And we're going to protect it by using the split braided sleeving that we also got from Painless. And then all we have to do is hook up the battery and all the lights. It's good to go. And now we can start to hook up some of the accessories like this transmission cooler with integrated electric fan that we got from Hayden. Using Painless Performance's weatherproof relay kit, I will crimp all the wiring connections, shrink the tubing with a little heat, hook up the relay, and the weatherproof circuit breaker, a flip of the switch to test.
A lot of us know how much fun wheeling at night is, but to be able to take full advantage of that, you gotta have some rock lights to see the placement of your tires. Now, normally you can use off-road lights, but in this case, we're gonna be using these LED lights that we got from Round Eyes. I'll show you how they look. Hey, Hutch, will you cut the lights, please?
Here we go.
The nice thing about LEDs is that not only are they super bright, but they draw almost 0 amperage. So you don't ever really have to worry about draining your batteries or killing your alternator. When positioning the rock lights, you want to get as much light to the back side of the wheels as possible. Pre-drilling allows me to use self-tapping screws with an eyelet for the ground.
When it comes to tube buggies and headers, you've really only got two choices. You can either build a set or find a set that fits. Now we lucked out with these new LS1 block huggers that we got from Hooker Headers. This is a super competition unit with an 1.5" primary into a 2.5" collector. And this super thick flange at the head will help eliminate any leaks.
We're gonna flow that exhaust through a couple of Flowmaster's Hush Power 2 mufflers. This is a fully still welded body, and it's got a unique flow-through design. Come on, I'll show you where we're gonna put them. Because of where the transfer case sits, there's a little bit of a lack of room down there. So we're gonna be putting them right about here for the effect of heated seats. Nah, I'm just kidding. Once we get the floors in, we're gonna be using this DEI heat shield. It's gonna block 85% of the heat, and it's gonna stick up to 450 degrees, so it's not gonna fall off.
We're going to use a Flowmaster universal tailpipe kit to get the exhaust from the header to the muffler. We'll trim some tubes to fit, and then tack everything into place, and cut a turn down for the tailpipe.
Back when the chassis was in bare steel, we welded on the mount for the hydraulic steering's orbital valve. Now that the axle's in place, we can go ahead and mount the steering cylinder that we got with the PSC off-road steering kit. All I gotta do is figure out where this thing is gonna be placed, and we should be good to go. With the tires and the cylinder in the straight ahead position, I will tack the mounts into place. Then I'll shoot some compressed air to cycle the cylinder and check the clearances. Perfect! Now all I gotta do is finish weld the tabs. Now to get that wheel to turn along with this wheel, we're gonna need to make a crossover steering rod that attaches this crane height clearance steering arm over to the other side. We're gonna be using 1.5" half-inch wall DOM tubing, and then we're gonna tap in some QA1 rod ends to each end.
Now the next piece of this hydraulic steering puzzle is going to be the pump that also came from PSC. Now the LS1 small block ships from GM Performance parts without any accessory drives. So we went to March Performance for one of their LS1 serpentine belt kits. It comes with all the brackets, pulleys, and idlers to get a serp belt on the front of our engine, and it comes in this billet aluminum show polish that they then put a clear powder coat over so the aluminum won't tarnish. Now the only issue we really have with this whole setup is this is an older style GM pump, and the LS1 normally uses a micro pump or a mini pump that's a lot smaller than this one. So once we get everything mounted, we're gonna have to fab up a bracket to make this pump work with the system. And the only real headache there will be making our bracket look as good as the stuff that we got from March. And with our axles fully assembled, we could go ahead and measure for and order our custom axle shafts from Superior Axle and Gear. Now the rear, all we had to do was send the old shafts out and have these new ones matched to them. But the front, since all we started with was the center section, are 100% custom. Ours are from Superior as well, and the inner and outer shafts will be connected with rebuildable CTM U-joints. And at the wheel, we will use Poly Performance drive flanges. With axle shafts in our differentials, we can go ahead and install our drive shafts. Now ours came from Denny's Drive Shaft. They're heavy-duty steel units with super strong 1350 U-joints at the axle end. Now the way you can make sure you have enough slip travel in your drive shaft is pretty simple. You just have to take 3 measurements. The first one, you extend your suspension all the way out to its limits and measure from the transfer case to the axle. Then pull the springs out and let it compress all the way, same measurement, and then the same measurement again with it sitting on its springs at ride height. Those 3 measurements to your drive shaft guy, you get a shaft that fits every time.
When it comes to the brakes on our Bruiser 8 chassis, there's a lot of scenarios that we discussed, and the most obvious would be to run a dual master cylinder. But the advantage of having an Atlas 2 transfer case is that you can run each axle independently and do front or rear digs, which means you can hit the brakes on one axle and the other axle digs in, allowing the buggy to do really tight turns. But then it came to us. Why run one pedal when we can run 2 pedals? So we called up Wilwood and they sent us 2 pedal assemblies and 2 7/8 rebuildable master cylinders. We built a custom mounting bracket so we can put the pedals side by side and close together. We're using Crown Performance braided lines for all of our brake lines. Using flex lines will make the install very easy and quick.
The LS series of engines is a little more complicated than GM's other crate engines. First of all, it does not ship with any accessory drives. So we went ahead and installed the March Performance full polish drive on the front of this engine. But the big difference is in the fuel delivery. The LS fuel pump in the tank has an internal return bypass. There's only one fuel line running up to the engine. But on any aftermarket fuel cell, like our tank from Rock Valley, it's going to have two lines, a feed and a return. So to run that type of system, you got to swap out the fuel rail. The fuel rail is simply removed from the top of the engine. Then the fuel injectors are swapped from one rail to another, along with the fuel pressure regulator. Then the new rail can be bolted to the motor.
We're going to be using Russell's Dash 6 steel braided line with an inline fuel filter. Now inside this fuel cell, there's a sock filter that'll keep the dirt from damaging the fuel pump, but this finer screen unit will help keep dirt from damaging our injectors. All right, now when you're running your fuel lines through the chassis, you want to make sure that you're keeping clear of any heat source. In our case, we have exhaust on both sides, and even if we run it down the middle, we still have a chance of getting heat from the transmission. So we're going to be wrapping it in this heat protective shield just to be safe. Now all we have to do is check the computer for codes and all our electrical connections.
Top up the fluids,
It's full.
flip the switches, and hit the key to hear it all fire up.
Baby, yeah. With both trucks trailered up, we headed to a nearby off-road park to give them a go. The inaugural run for the Spyder.
You wanna come for a ride? Jump in, man.
And hopefully third time's a charm for our Ranger.
The hardest job when building our Poison Spyder Rock Rod was creating an entire front axle from scratch, starting with only a center section. But once on the trail, it was obviously the right decision. From the custom width to the beefy superior shafts and CTMU joints, we knew it could handle anything we threw at it.
With ginormous flex, thanks to our double triangulated forelink and Bilstein rock crawler coilovers, the Spyder tackled with ease obstacles that required a lot of articulation.
Gearing is the Spyder's secret weapon. With 529s in the axles, ultimate low Atlas 2 with a 5-to-1, and our deep first gear ratio in the 4L65E transmission, the Spyder crawled up most trails just off idle. But that doesn't mean it's only built for slow cruising. Chicka-pow! Buck-a-cheer!
Good job, good job.
It's that hydraulic steering, because you don't have full hydraulic steering when you're on your side like that. You can't get the tire to turn back underneath you. But with full hydraulic, you're basically lifting the whole weight of the truck up, and then you just put it in reverse and it'll just back right out.
The Ranger finally performed like a champ.
Come on, just a little more throttle. There you go, there you go, there you go.
Agile on the rocks. And a beast out in the open.
Together, a great juxtaposition. One, a tube chassis purposely built.
The other, a pickup that was cut up and rebuilt. Both of them totally wicked.
I just need one dry spot.
One lap.
go, guys. 2 trucks, 1 back on the trail and 1 on the trail for the first time. I think all in all, pretty good day. What do you think?
I think they both kicked some hardcore. They did very well. They handled awesome. I think we did a really good job.
It was a good day.
You should be proud of us.
Hey.
As much as we're proud of us.
Now, I'm sure a lot of you guys recognize the Poison Spyder that's up on the left. We originally built this rig way back during the very first season of Extreme 4x4. Well, that was over 4 years ago, and to say that this buggy has had some serious trail time would be an understatement. We've been wheeling the Poison Spyder whenever we get the chance. It's kind of like our unofficial company car. And just like all company cars, the Spyder gets beaten within an inch of its life and almost no maintenance is ever performed on it. Well, today, that's going to change. One trend that we see a lot of nowadays are buggies changing hands. Some guys are selling to build something bigger and better. Others are moving away from 2 buggies to build Jeeps and other dual-purpose rigs. Either way, a used buggy can be a great deal, but before you hit the trails, you'll want to spend some time looking it over. And so that's what we're going to do here today. Using our Poison Spyder as an example, we're going to show you guys some of the maintenance you should do on your trail truck, either between rides or at least once a year. Or if you've bought a used rig kind of like our Poison Spyder, how to assess trail damage that's done to it, what you need to fix, as well as just basic maintenance before your first time out on the trail. We're going to start with the front axle joints. Now, we originally installed CTMs into our shafts, but it's still a good idea to periodically check these for wear about once a season. If this joint fails on the trail, it often causes both axle shafts, inner and outer, to break. Now, the CTM joint uses a bronze bushing instead of needle bearings. If we had any signs of wear, we could rebuild this axle with a new bushing. These ones here are good as new. Now, the next thing we want to check on our buggy is all the suspension links. Now, just like most tube buggies, our Poison Spyder has a pile of rod ends in both the steering and all the suspension mounting points. Now, before you go on any trail ride, you want to quickly crawl underneath your buggy and make sure all the jam nuts on these links are tight. If they loosen off on the trail, you can actually bend the shank on that rod end. That's a very common problem. A way to check to see if it's bent is to simply loosen off all the jam nuts and turn the link by hand. If you see the end of the link moving up and down as you turn it, it means the shank on that rod end is bent. You should replace it right away. Now, if you've bought a used buggy and you don't really know the history of it, it's a good idea to take the link out and inspect it. With the axles supported, we'll remove one link end at a time and check the Teflon block to make sure that it's not loose or worn out. With the covers off, we can get a good look at the gears. We want to check for cracked or broken teeth on the ring gear. And on an axle like the Dana 60, we can usually get a good look at the pinion as well. Now, if you want to go even further, you can also check the backlash and the gear tooth pattern on the gear set. Now, the term nut and bolted is often used when talking about a race vehicle. What you're doing is going over and checking all the critical fasteners, things like suspension mounts, shock mounts, limit straps, and engine mounts. Anything that if the fastener failed, the resulting effect could be a catastrophic issue. Now, you're not trying to make it tighter. All you're doing is basically checking to make sure there's no fatigue in the bolt. If this is your own personal buggy, you might want to do this about once a year. But if this is a buggy that you just bought used, you should do it right away. 2 wrenches work well for this, and if you find a fatigued or worse broken bolt, be sure to change it right away, preferably with one of a higher strength rating. I like to remove any grade 5 bolts I find and replace them with grade 8s. We won't just be replacing the fluid, we're going to be upgrading it as well. Royal Purple full synthetic gear oil in the axles will help the gear sets last. A new oil filter and Royal Purple 5W30 in the engine will help us tap into all the power the LS has to offer. With the transpan clean and no clutch material present, we know our automatic is in good shape. So Max ATF will help keep it that way. Then finally, a basic tune-up with new plugs and servicing the air raid filter element with their recharge kit. Now, we're not just going to be talking about maintenance today. You also want to periodically check your rig for obvious signs of trail damage. Now, we wheel the Spyder all the time. Most recently, we had it out on a trail ride, and the guys from Crawl Magazine caught a pretty serious rollover on film. Now, when we got the truck back here at Extreme, we noticed that the chassis itself had been tweaked in a way that we must address it. You can have a look. That first initial point of contact is the top part of the bend, and you can see that that A-pillar is leaning way over towards the driver, and this one here has gone almost vertical. What that means is the entire top part of this chassis has been twisted over. Now, you can see the initial point of the bend right down there at the dash bar, and the problem with that is if we don't fix this problem, it's going to keep bending if we roll this truck over again. Once a tube starts to fail, it wants to just keep going. That's how it's designed. Now, there's a couple of ways that we could go ahead and fix this. We could throw a jack in there and try to press the chassis back into shape, throw some gussets in it, and hope for the best. But the better way to do it is to go ahead and clip the whole upper section of this chassis off, redesign it, and build it from scratch.
Kind of a convertible.
It is a convertible. Rock crawler. Not safe though. But cool looking. Oh, see how close to the lens I can get. Ooh. Now, our BendTech program tells us how far we need to rotate the tube in the bender. Now, this tube needs to be turned 80 degrees this way, but it's hard to visualize the centerline axis. So how we do that, simply mount a muffler clamp onto the tube, and then when we turn the tube on its center axis, we'll be able to see how far it's going just by reading that angle finder. Once we hit 80, we're ready for the next bend. Grab this end, Chris. Yeah, sure.
Now, since we're tying the cage into the original chassis, we want to add a slug at the joint to reinforce it in case of a rollover.
Now, we were able to draw the entire top half of the chassis on the computer and then render it to see what it would look like. Now, you can see the difference here. We have these two little windshield bars here to really close up this gap so the front shouldn't rack. All of these points triangulate off that one point into the main bar. Once we get it in here, we'll probably drop in a couple more tubes to add some triangulation to the center hoop. But all in all, it might not be as fancy as what was there, but it'll certainly be safe. Now, so far today, we've shown you some of the key things you need to maintain on a buggy that you've been wheeling for a while. We also showed you how to assess some damage and then repair it if you've bought a used buggy that's been wheeled pretty hard, like our Poison Spyder. But there's more to it than that. When you get a used buggy, you want to change some stuff, make it your own, even if it's just a coat of paint. And that's one of the reasons why we completely replaced the top half of this chassis. When we first built this truck over 4 years ago, there was only room for 2 seats in the front, and that's because of the design of the back half of the cage. So by redesigning and pushing the roof up a little bit higher, we now have room to make the change we've wanted to do since we first built it, and that is a back seat. Now, we called the guys at Mastercraft and had to make this custom bench that fits right in this small part of the back of this chassis. Now, the nice thing is it's a full suspension seat, just like our Rubicon seats up front, and they were able to match the fabric perfectly with the red tweed inner as well as the Dirt Sports cover with the carbon fiber inlay in the end. Now, it is a little tight back here, but you got lots of headroom, a little bar to hold on to. All in all, it's gonna be a great place to sit to go four-wheeling. Well, for Chris to sit.
Right. Now, when we had the Spyder first on the trail, we had the Optima battery strapped to the tubing. Although that did fine, we picked up this battery box from Summit to help protect it a little bit more.
Now we're not only going to repair the structural damage to the Spyder today, we're also going to take care of some cosmetic stuff. When we flopped this truck, basically rode off this steel hood. So we're going to replace it with a brand new fiberglass one that we got from 4-Wheeler Supply. Now this is one of their rock crawler hoods, and it has these integrated high-line fenders that if you bolt this onto a stock TJ, will give you 5.5 more inches of tire clearance. Now this is not a stock TJ, but one thing that's been bugging us about this chassis is this fender bar right here has been contacting our tire when the suspension is in full stuff. So we're going to be able to remove that and get more articulation. Now I'm sure some of you guys are wondering how we're going to deal with all new tubing on the top half of this chassis when the bottom half is already painted. Well, it's going to be a simple two-tone with a little bit of truck bed coating. That completely changed the look of that truck.
Yeah, it looks good.
Now, those of you with a keen eye will realize that our Spyder is rolling on a new pair of shoes. Now, we did not replace the tires on this buggy because they were worn out on the trail. 2 of them got worn out really quick when the guys at Muscle Car made a comment about a rock crawler not being able to do a burnout. Well, they were wrong. Now, obviously, those types of shenanigans will wear a tire down pretty quick. So we went ahead and replaced all 4 on the Spyder with a set of brand new Pitbull rockers. Now, these are 39.5 inch tall by 16.5 inches wide. Now, they are a bias ply tire with an alternating tread block design with integrated siping cut into the larger blocks. Now, the siping actually opens up when the tire heats up, and that helps with the clean out. Now, these side biters will really tear into the dirt when the tire is aired down, as well as this integrated rim guard will protect our wheel from trail obstacles when we're in the dirt. Now, that's one upgrade that we're doing to the Spyder, but one other thing that we always wanted to do was put a winch on this front plate. We just never seemed to find the time. And now that we've been wheeling this thing more and more, having a winch is definitely a good option. So we went ahead and picked up a Warren 9.5 Ti thermometric winch. Now, this is a 9,500-pound pulling winch. It has 125 feet of 5/16 aircraft cable, and the nice thing about the thermometric feature is right on the remote is a small LED. If the motor begins to heat up, the LED will light up and let you know that you need to let your winch take a little break on those long pulls. Now, all we got to do is mount this to the front plate that's already there. Be ready to go wheeling. The winch plate on the front of the Spyder is built into the front stinger. And once 4 holes are drilled, the winch simply bolts in place. Now, since we've already completely changed the look of our Spyder, we decided this would be a great time to go ahead and add some body panels. Now, this will completely cover up the tubing on the side and change the look of the truck completely. I went ahead and made a rough cut on this 065 aluminum, held it up against the rig, and then just traced it out. And once we have these finished cut, I'll go ahead and spray them with some bed liner to match the hood. My new co-host. Let's go four-wheeling! Welcome back to Extreme, where today we showed you how basic preventative maintenance on your trail rig pays dividends, especially here. I mean, you want to spend a beautiful day like this behind the wheel, not on your back doing repairs. Which brings us to our Spyder. We've beat our rig to a pulp over the years, so it was time for some improvements. First, a new set of shoes. We chose the Pitbull rockers. We stepped up to a 39.5 to give us a little bit more ground clearance. It's a full bias tire that really shines when it's off-road. We're gonna air down the tires because the sidewalls just aren't flexing. They're brand new, so we expect them to be a little bit stiff, but we're gonna air them down just a little bit more, try to get them to take some of that bounce out of the rock. Oops, too much. We moved the fuel cell back and completely rebuilt the cage. You can see the triangulation in the DOM tubing and how intersect points make this way stronger than the original design. And with more headroom, we added a third seat.
Are you Danny the plumber?
I'm not a plumber, I'm a cameraman.
You good, dude? Here we go. That's Southern style wheeling. Well, Danny, tell him how comfortable the ride was back there.
Oh, it was just like riding in a Cadillac.
All in all, a good day wheeling. Gorgeous weather, one heck of a lunch.
Happy crew is a fed crew.
And proof that some simple routine maintenance can keep even our 5-year-old buggy on the trail where it belongs. Until we trash it again. Just leave it here, we got others.
I'm cool with that.